Hello friends, I welcome you all on my YouTube channel Java Interesting Topics. Friends, today I gonna cover one of the exciting topic related to the Java 8, and the topic name would be interface evaluation using static and default methods. So let's start related stuff related to this topic itself. So this topic would be really long topic, so I decided to split this topic into the multiple parts. So there would be a lot of milestones we would be covering along with this topic. So let's have a look at the roadmap of the default and static methods that we are going to learn along with this session. So first thing, starting with the prerequisite. So interface and abstract class, and secondly the compatibility related to the binary and source code compatibility. These are the prerequisite. I'll talk around this after a little while. Let's complete our roadmap first. So the second thing that is I will cover along with this session is the question, like what type of questions, like what is default method, what is static method. So that would certainly be covered along with this session. And again the why related question, that why default and static methods introduced in Java 8, what are the needs to introduce these kind of methods in Java 8. And further, definitely we'll look into the real world use case. Like I'll walk you through the real world use case of evolving an API and the problems that may arise whenever we evolve our any existing API. So our learning progress will not stop here only. I will cover a lot more session around this, and that would be like the fifth thing we would see, like the JDK libraries. We will see the existing similar example in JDK libraries also along with this course, and compare with abstract class. Again, that is also one of the important topic, like our interfaces like abstract classes now after the new changes introduced in Java 8, that would also be covered. And definitely we will look into the inheritance rules, and interface have concrete methods now. So how to resolve ambiguities of multiple inheritance. So a lot of rules hidden behind the default methods. So all those interface rules we're gonna look along with the series of default and static interface methods. And last but not least, that would be the interview questions, of course. And I'll post a list of frequently asked interview questions around this area, and that would summarize our entire session. So very long journey uh, in this learning, and I'll be split that entire session into the multiple parts so that you can easily digest the concepts. So let's start with the first part, that is prerequisite. So with today's session I'll be covering the prerequisite part. So first part is interface and abstract class. Friends, interface and abstract class are must to know a kind of concept before reading about the static and the default method which were introduced along with Java 8. So I would recommend, if somebody is absolute beginner and have not yet covered the interface and abstract class concept, then do not go ahead with the session, because you would not get much if the interface and abstract class concepts are not clear to you. So for that also I can help you out in this. If you are beginner, I have already posted or uploaded one of the session around the interface and abstract class, which name is diamond problem and interface in Java for absolute beginner. So I would highly recommend this tutorial for those guys who does not have any idea about or much idea about, or at least the basics are not clear about the interface and abstract class. This session is around 95 minutes long, and if you go through that session, then certainly your concepts would be clear around interface and abstract class. I'm not going to cover the interface and abstract class basics along with this session. So go ahead and watch that particular video first if the things are not clear to you before understanding the default and static methods. Now coming to the second prerequisite part, which is compatibility. So we would try to understand that what is binary and what is source compatibility along with this session. So this part today I'll be covering first. So let's go ahead with the compatibility stuff first. Friends, in Java we have three different types of compatibility, that is binary compatibility, source compatibility, and behavioral compatibility. So compatibility here means whenever we change or whenever we make changes anything into our existing program, like with the time our library get evolving. So what is an impact on the dependent program? That is just through a different kind of compatibilities that is like binary, source, and behavioral compatibilities. So let's look these compatibility one by one quickly, and I'll showcase the practical example also around these compatibility, especially the source and binary compatibility, because these kind of terminology you would see lot more when you will explore a lot of things around the default and static method here and there. So it's always better to clear such kind of concept first. So let us start with the binary compatibility. So one of the example sets or is like if you don't recompile your code and if it is still working, then it's called binary compatibility. So example could be adding a new method to an interface. Don't worry if you did not understand this, I will thoroughly showcase this binary compatibility through an example set itself. Now let's go through the practical part first, and then we will jump into the let's go through the theoretical part first, and then we will look into the practical part later on. Secondly, the source compatibility. If we try to understand the source compatibility, so that is like if you recompile your code and if it still works, then it is called source compatibility. So again, example is like change in the argument list of any class like C1, and its dependent class should compile fine without any changes. So this also we gonna look around. And the behavioral could be running a program after a changes with same input results in the same behavior. Adding a method to an interface is behavioral compatible because the method is never called in the program. So let's look into the practical part directly, and the things would get more clear around the compatibilities, what is compatibility and what are issues around this. So my example sets would revolve around the interfaces and related stuff only, so that when we would learn about the default and static methods which have been introduced with the in Java 8 with the interface would make more sense to you guys. So let's quickly jump to the IDE, and first thing first, we will be looking into the binary compatibility first. So let me close the other unrelated program as of now, and let's look into these two programs. So this is a pretty much simple program. if you look here, I have an interface I1 and just have one method inside that interface I1. The method name is M1. Now let's look into the class implementing this interface. So the class A is there and which implements the interface I1. So have just overridden with one of the print statement this M1 and just calling this method M1 here. So obviously nothing fancy here. So when I run this program, let's have a look at the output of this program. So the output is inside M1. Now let's look into the binary compatibility over here. What is binary compatibility and how we can understand this part. So to understand that part, I'll have to go out of my IDE and let me show this example through the console itself other than the IDE. So let's come here and let me open these two program into the notepad plus plus and see here the same program. As of now I have commented out this part. So first thing, let me compile this program real quick one more time here. Let me go to the command prompt and just type java c star.java. It should compile both classes. One is interface and other one is the class. And let me run the class now and see the output. So here we go. We have an output with us. So before moving ahead around the compatibility, I would like to showcase you one thing around this. That thing is the have a look at the Java bytecode as of now, and I'll recompile one of the program and show you the binary compatibility. So to look into any bytecode, just type java p command and we would like to see the entire verbose. So I'm typing in minus v and followed by the class which we would like to at this time I would like to look into the interface one. So let's look into the interface verbose. So see here, the only one line I would like to show you along with this program is the instruction set about this line, this highlighted line. It has the reference of method M1, right? The method M1 is one of the instruction set has been given over there, and the same method M1 should have been used into the other class also, which is class A. So we can quickly look into the that class bytecode also, and we'll come back on this one more time. So again, look into the verbose part, and this time around I would be looking into the class A bytecode instruction. So pretty long instruction, but if we look around the method M1 here, so it has in its instruction sets the name and type of the method M1 it is calling. So these instruction sets help the program out at the runtime that how it needs to be run. So let me do few more things now, and now I'll showcase you what is binary compatibility. So as I explained in my theoretical part, that whenever we make changes anything into or any program and then retest the dependent program, then the compatibility is checked. So let us look into the binary compatibility. So say for an example, you have written some API, this I1 interface, and over the period of time you realize that this API need to be evolved now and need to introduce few more stuff. Like in this case, I'm introducing one more method here, and now I will recompile this particular method in the console. So we all know that if we introduce any new method into the interface, then that related class must implement that method. And if we do not do this, that particular class does not get compiled, and it does not doesn't allow us to go ahead. But what is happening here, that in our previous version 1, the class A was referring to the method 1, and the interface only had the single method inside it. And now we have introduced one more method, so I would not touch anything around the class A. And let me compile the interface I1 first, then we will retest the class A. So I'm just doing Java C and i1.java. One second. Okay, I just made the mistake in typing i1.java and oops, one more time mistake, Java C. So here it is. I have compiled my code, and if you would like to see the interface bytecode one more time, then you can look into that. And this time around, it would have the uh, bytecode instruction for method M2 as well in its instruction set. Look at here, the M2 and M1 both exist now. Now let's run the our first program, the class A, Java A, and here we go. We still have the output. It is not complaining anything. So this thing is called binary compatible. Until unless we do not recompile our class A, it would not complain anything. Its runtime system, its bytecode instruction still have the information about M1 only. So without any problem, this class A would keep working in this way. So if I recompile this like Java C A, then the problem should start. We should have problem in that case, definitely. See here, the one problem is there. So meaning to say, the binary compatibility, the first thing which we learned, like if we don't recompile our code and if it still works, then that is called binary compatibility. Now let's come to the second example set, what is source compatibility, and we will try to understand that part now. So coming to the other program, like I have this program for you. So the class name is source compatible, and I have one of the method in this class, add product, and add product has array list as an argument here, and we are just printing whatever the products have been added to this particular list in add product method. And secondly, the client class, in other terms the dependent class who uses the code of the source compatible class, is what it does, it add a couple of products in it and passes that products to the add product method of source compatible. So again, a pretty simple program, nothing fancy over here. And if I run this program, it should show us the P1 and P2 here. So let me run this. Okay, so we get the desired output. So let us look into the source compatibility part now. What is source compatibility here? So to explain this also, let me go to the console one, because that would be the better place to show the bytecode and other stuff. So let me show you the program, the same program we have in the IDE, and I gonna compile through the console this program. So we are at this location and I'm going to compile this program by hitting the command java c star.java. So it has compiled both of the classes, and let me run the client class now. Source compatible client. So it should give you the desired output like P1 and P2. Now let's come back to the definition part one more time. We can relook that part, what definition says for the source compatibility, and so that after that I'll make the changes into one of the program, and will observe the dependent program then. So if you recompile your code and if it still works, then this is called source compatibility. So one of the example sets like change in the argument list of class C1 and the dependent class should compile fine without any changes. So we gonna try this out now. So what I'll do in this program, what I have done, I'm passing as an the argument list as an array list. I know I can pass the parent class reference also in the list. So no matter if client pass the argument of array list or any other list, that should work fine even after that. But before that, let's look into the source compatible client bytecode once. So what reference it has in its bytecode instruction set. So for that, again java p minus v, and let me do this. All right. So have a look at this instruction set. It has the instruction set of array list, right? So it would expect like in this instruction set that in add product it is passing an argument of array list. Now let me make changes into this source compatible class, and this time around I'll keep it list only other than the list, and let me recompile this class one more time. So let me clear the console and hit the java c this program one more time. So what will happen now if you try to think on this program, as we have seen the instruction set of the dependent class that has in its add product method, the instruction set was related to the array list. But now in my target program or this class, the source compatible class, I have changed this stuff. So I'll have to recompile this program, and after that it should work fine. If that happens, I am not making any change into the source compatible client, and if I recompile it and due to the changes in the other program, if it still works fine without any issues, then that would be the source compatibility for me. So let's look before, let me run this before any changes, and it should cause a problem to me because I have made the changes into the other class. So if I run it, definitely I'll get this error, no such method error, because the add product in its instruction set was array list. So let me recompile it one more time. And let's run one more time. So that becomes the simple case now. So same output should occur here. So if so far I haven't discussed anything around the default method and static method, but these terminologies like the binary compatibility and source compatibility, and you have seen the different definition around the binary compatibility. In first case, we did not in our one of the example cases for binary compatibility, that was related to the interface. When we try to introduce one of the method inside our interface, that did, our target code or the client code was intact and was running fine without any issues. While in the source compatibility, we have seen like if I change one of my program and the dependent program was still working fine, but that was after recompilation, not without recompilation. So these are the different example sets of binary compatibility and source compatibility that would be useful to understand the concepts around default and static method. So that's all I have for you guys in this session. I hope you have enjoyed this video, and if you like my videos, my way of explanation, then please subscribe my channel, and the remaining part I'll be upload the default and static method related parts in coming up sessions. Have a great day ahead, guys, and I'll see you in my another session. Thanks. Bye.